In this video, we're going to learn how to solve quadratic inequalities graphically. And just because the title doesn't say factoring doesn't mean you're getting out of factoring. It is one of the steps. So as I'm sure has been reiterated over and over and over again, if you are having trouble factoring, you need to sit with your teacher and practice until you become competent at it, because factoring is just going to be part of so much from here on out. And it doesn't end in Unit 2 either. Factoring is going to persist through the whole rest of the year. You need it in pre-calc, you need it in calculus, the list goes on and on. So please make sure that if you are still feeling like you aren't confident, that you get some help from your teacher. So solving these quadratic inequalities graphically, if it's an inequality, that means we have a less than, a greater than, a less than or equal to, or a greater than or equal to. So our first step is we're going to replace our inequality symbol with an equal sign, and we want to make sure it's in this equal to 0 form. So if there's some terms that need to be combined or something like that, we would do that first. So here we've got x squared plus x minus 2, and we're going to pretend like it's an equals, even though that didn't look like one, equals 0. Then we're going to find our zeros, which are our x-intercepts, by factoring. So x squared plus x minus 2, there is no GCF. Definitely not a special product because this is a minus, so chart factoring. So I'm looking for what multiplies to -2 and adds to +1. So that would be +2 and -1. So if I solve this, zero product property says if this equals 0, then we would subtract 2 from both sides. So x equals -2. This one would give me x equals 1. So that means that my x-intercepts are at -2, 0 and +1, 0. So I am going to need to graph y equals ax squared plus bx plus c. So meaning I'm going to graph y equals x squared plus x minus 2. Now, when I do that, this can be a rough sketch other than the zeros that you already found. So if you want to find the exact vertex and other points, you can, but in this case, it's really not going to be necessary. So I'm going to plot -2, 0 and 1, 0 exactly. The rest I'm just going to kind of guess and draw a very rough sketch. I put these here so I would remember to graph them, but really you don't need to count out anything except for the x-intercepts. So you don't even need a scale on your y-axis. What you do need to know is which way it opens. So in this case, because it's a positive a, because it's 1, we know that it opens up, and I know that my vertex should be about halfway between those x-intercepts as far as the x-coordinate, so I'm just going to draw it like that. If you really want to know where it is, you can use your calculator or do the other tools you've learned for finding that vertex. The reason why we don't need the entire thing is because the rough sketch we're going to use to just solve this visually. So we don't really need any exact values other than those x-intercepts. So we need to now identify the x values, and this is huge because I get so many people who try to do y values, but it's x values for which the graph lies below the x-axis if we have a less than or equal to, or above the x-axis if it's a greater than or equal to. So we look at our symbol. Our symbol is less than, so that means below. So the part of the graph that is below the x-axis, I call this like squiggling it. I would suggest you do that or color it if you have colored pencils or a highlighter. This is the part that's below the axis. And because this doesn't have an equals, that means we should not be including the boundaries. So this is what's below. Visually, that kind of shows us the y values. It's a little loop. What we need are the x values because those are going to be the answers. So the x values that give me this loop are the x's in here. these are going to be my answers because these x values give me this part of the graph that's below the axis. So here x is -2, here it's 1. Remember we said we can't include the point on the axis because there's no equals here. So that means that I know that x is going to have to be between -2 but not including it and +1 but not including it. And this is actually the answer. Now, we're going to do one more, and then I'm going to give you a couple hints that might help you as you go to solve these on your own. So, next one, we first replace the inequality sign with an equals because that's the only way we can use the zero product property is if there's an equal sign instead. So we just substitute. And then we're going to factor this guy. There is no GCF, can't be a special product. So this is either guess and check or slide divide. Again, at this point, it's your choice which of those two methods you want to use. Because 2 and 3 are both prime, I'm going to guess and check because I know it needs to be 2x and x. And I know because this is a minus that it's going to be -3 and -1. And I'm pretty good with factors, so I can quickly tell that in order to get -7, I'm going to need the -3 to go with the 2x. That gives me -6x. This gives me -1x, which is -7. So if 2x minus 1 were to equal 0, that means add 1 to both sides. 2x equals 1, which means x equals 1/2. This one, easier, just a one step, add the 3, and x equals 3. So that means I've got intercepts at 1/2, 0, and 3, 0. Those are the only things that need to be exact. This one also opens up because it's a positive a value. So it looks something like this. Our symbol this time is a greater than or equal to. So when I'm doing the little squiggling, I need to identify what is at or above the axis. So at the axis would include these endpoints. Above would include this part of the graph and this part of the graph. So remember, the visual that I've just drawn here is really giving me kind of the y's, and I need the x values. So the x's that give me like points up here, for instance, this point is when x is 0. And ones way up here would be x's that are over here. So this we know is x equals 1/2. That point is a solution, but also all the x's to the left are going to give me parts that are above. So I know that x less than or equal to 1/2 provides solutions. Over here, to get this part, this arrow of my parabola, I need my x's to be 3 exactly, which would give me this point, or bigger, because bigger than 3 is over here, which gives me the points way up here. So, or x is greater than or equal to 3. So, hopefully that makes sense what I did here. I want to give you some hints that will help you, just some rules that are kind of always true. When you are having an original symbol of one of these, then you're going to use those in the answer. If you have less than or equal to, greater than or equal to in the original, you're going to use those same symbols in the answer. So original had an equal sign, answers have an equal sign. Original did not have an equal sign, answers do not have an equal sign. So that's one thing that's always true that can help you. The other thing that can help you is the way the picture looks. Because everything in this section is a quadratic, that means it's always making a parabola. And while the parabola could definitely open down, when we are looking at these, Most of the time when we're identifying what is below the axis or above the axis, we're either going to be squiggling a loop or arrows. If you squiggle a loop, that means your answer should be this kind of inequality sandwich. So where we've sandwiched x between two other values. When we have the arrows that are the solution, we're always going to write an or, meaning that we're going to have less than or equal to something or greater than something else. And that is always true. If it's arrows, you're going to write an or with two separates. If it's the loop, you're going to write an inequality sandwich. So hopefully those rules help you out.